So good morning dear students. Now in this video, in the today's video, I will be solving some of the questions which you have the doubts. That means so many students asked me for this solution of this question. So I'm taking those questions in this video. Okay. So please try to understand them because they can be important. Okay. Okay, let's start with this question. It says 2 cos y is equal to x plus 1 upon x. Then prove that cos 2y is equal to 1 upon 2 x square plus 1 upon x square. Please solve these questions in the fair copy. Okay, so let us take the given thing, this here, squaring both the sides. So it will be 4 cos square y, and the square of x plus 1 upon x is x square plus 1 upon x square plus 2. Because 2ab, this 2a, x and x will be cancelled, so 2 will be left. Now take 2 this side, so 4 cos square y minus 2 equal to this. And you can take 2 common from this one, so 2 cos square y minus 1 equal to this. Now by the identity you know 2 cos square y minus 1 is cos 2y. So take 2 in the denominator, and hence this question is proved. Okay, let us come to the next question. It says if tan square x is equal to 2 tan square y plus 1, then show that cos 2x plus sin square y is equal to 0. We have to show. I'm taking this given part, tan square x is equal to 2 tan square y plus 1. Now I'm writing this 2 tan square y as tan square y plus tan square y and plus of 1. Okay, and this is as it is. Now tan square y plus 1 will give you sec square y by the identity. So this is the step. And now I'm writing this tan square y as sin square y upon cos square y and sec square y as 1 upon cos square y. And as it is a like fraction, so cos square y, and in the numerator 1 plus sin square y. So tan square x can be written as 1 plus sin square y upon cos square x. Now take LHS. In the LHS you have sin 2x, and we know that cos 2x you have. So cos 2x, one identity we have, that is 1 minus tan square x upon 1 plus tan square x. Okay, so why we are using this identity? Only because we have the value of tan square x here. That is why we are using this identity. Alright, so now just replace cos 2x by this value. So we have replaced here, and plus of 2 sin square y as it is. Now in place of tan square x, we can write 1 plus sin square y upon cos x. So here also and here also, and plus of sin 2y as it is. Now how this step comes from this step, I have taken the LCM. This cos square y is multiplied with this 1, and here also in the denominator this cos square y is multiplied by this 1, and the denominator of this and denominator of this, that is, it was cos square y, so it was cancelled, and you are left with this thing, and plus of sin square y as it is. So after this, see this cos square as it is. Now I am writing this 1 as sin square y plus cos square y by the identity, and minus of sin square y. And here as you see that cos square y plus sin square y, this will give you 1. So 1 and that 1 plus 1 will be 2, and plus of sin square y which is going on. Now multiply this minus inside, so minus of sin square and minus of cos square minus sin y upon 2, and this is as it is. And here you can cancel this cos square y to cos square y. You are left with minus of 2 times of sin square y upon 2 plus sin square y. This 2 and 2 also you can cancel, minus sin square y plus sin square y, and when you cancel you will get 0. So we need to prove 0, hence proved. Okay, let us come to this question. It says prove that 1 plus cos square 2x is equal to 2 times of cos to the power 4x plus sin to the power 4x. This is cos square 2x, which is cos 2x the whole square. Taking LHS, we are going to take LHS. Okay, and as we know that cos 2x is cos square x minus sin square x, so we are going to use that identity. And why we are going to use that identity? Because it is somewhat relating with our proof. So what you do, you always just notice your proof, what you want to prove, and you go according to that. Okay, so we are taking this identity and replacing this cos 2x as cos square x minus sin square x the whole square. Now use a minus b the whole square identity. Cos square whole square will give you cos to the power 4, sin square whole square will give you sin to the power 4x, and minus of 2ab, that is 2 into cos square x into sin square x. Okay, just keep it as it is. Now understand one concept. You need to use this sum in, like, if you solve the trigonometric question, you need to use this concept. So what is that concept? From here I'm going to just tell you, that is, as we know that sin square x plus, if I ask you what will be the sin square x plus cos square x the whole square, so you'll tell me sin to the power 4x plus cos to the power 4x plus 2 cos square x sin square x. But your sin square x plus cos square x is 1. So 1 the square is equal to sin to the power 4x plus cos to the power 4x plus 2. 2 cos square x is sin square x. Now what you do, take this term this side. So 1 minus 2 cos square x sin square x will give you sin to the power 4x plus cos to the power 4x. Why we have done this much? Because we need to replace this thing. Sorry, we need 1 minus 2 cos square x minus sin square x, and in our LHS we have 1 and minus of 2 cos square x sin square x. So substituting, we are substituting in place of 1 minus 2 cos square x sin square x as sin to the power 4x plus cos to the power 4x. So this is here as it is, and in place of 1 minus this one, we are replacing this sin to the power 4x and cos to the power 4x, and this is 2 times, this is also 2 times, taken 2 common, and this is your final proof, which you won't. Okay. All right, please try to focus in this question. This is somewhat complicated, but we need to understand how to solve these questions. Actually, this is not complicated. If you understand the criteria, you know, all the things will be very easy for you. Okay, how? See, you are given sine 6, sine 46, sine 66 and sine 78. We have to prove this is equal to 1 upon 16. So how I'm starting the question and how I'm pairing the things. See, I'm taking sine 6 and sine 66, and I'm taking sine 42 and sine 78. Why? Because on adding 6 and 66 we are getting 72, and on subtracting we are getting 60. 72 can be molded as 18 or 36, we can mold easily, and we already know, and I have taught you that what is the values of some special angles, that is sine 18 degree, sine 36 degree, like that. Okay, and when you add 42 and 78, you are getting 120, and if you are subtracting, you are getting 36. Okay, so that is how, this is our intuition to just pair it. So these two are paired and these two are paired. Now I'm multiplying 2 in this one and this one. These two things we have, and we are going to use 2 sin x sin y identity, and here also 2 sin x sin y. So this 2 I have given to this 2, and this 2 I have given to this pair, and 2 into 2. 2 2s are 4, took out, and I have used the identity 2 sin x sin y, which is cos x minus y minus cos x plus y. So cos x minus y minus cos x plus y, and in the bracket again here cos 78 minus 42 minus cos 78 plus 42. Now 66 minus 6, 60 degree. Okay, here 72, here 36, and here 120. We know the value of cos 60, that is half. I have written. Okay, and just wait, this cos 120, that is negative of half, so minus minus plus half. Now I have written this cos 72 as, can we write this 72 as 90 minus 18, and cos 90 minus 18 will give you sine 18, because cos 90 minus theta will be sine theta, so sine 18, and this cos 36 is as it is. Now we know, or I have taught you the values, how to find the value of sine 18, and so I'm directly putting here. So sine 18 is this and cos 36 is this. I'm writing this half here. Okay, half minus this and half plus this one. We cannot use a square minus b square identity, a plus b, a minus b, because these two are different. So we cannot, so please don't be in that confusion. Okay, be very careful. I'm solving it. Okay, so like after this step I've taken LCM here. So the LCM will be what? 2 minus root 5 minus 1 whole upon 4, and here taking LCM to make 4 as a like fraction, so I've multiplied 2 plus root 5 plus 1 upon 4. 4 into 4, 16 into 4, 64. I've written here. Take minus inside, so 2 minus root 5 and minus minus plus 1, and 2 plus 1 3 root 5. 2 plus 1 is what? 3. 3 minus root 5. 3 plus root 5. A minus b, a plus b. Now you can use here a plus b, a minus b identity, which is a square, 3 square, 9, and root 5 is 5. 9 minus 5 will give you 4. 4 upon 64, that is 1 upon 16. So that is how we have done this question. Okay. Okay, now please try to focus on this question. It says cos cube x plus cos cube 2 pi plus 2 pi upon 3 plus x plus cos cube 2 pi upon 3 minus x is equal to 3 by 4 cos 3x. This is the question. Okay, now in this question, you can solve this question by two ways. You have two ways to solve this question. One, the very general way is what you do. See, use cos x plus y identity. This is whole cube, so you can write this as whole cube. This also as whole cube. So first of all, you do cos x plus y identity and cos x minus y identity. And then after that, you use a cube plus b cube identity, or else you can use a cube plus b cube identity here itself, and then you solve it, and that will go a very long method. You can go by that also, and you need to just use more identities on identities, and you have to solve it. One very easy method, let me explain you how. I think you have seen this formula, that a cube plus b cube plus c cube minus 3abc is a plus b plus c, a square plus b square plus c square minus bc minus ca, and minus of ab. In the 9th class, you have seen this identity. Now there is one condition, that if your a plus b plus c becomes 0, that means this bracket becomes 0, then 0 multiplied by this bracket will be all 0, and finally you will get a cube plus b cube plus c cube minus 3abc equal to 0. And when you take minus of 3abc that side, so it will be plus. So a cube plus b cube plus c cube will be equal to 3abc, provided your a plus b plus c should be equal to 0. So let us just check that in this is also cube, this is also whole cube, and this is also whole cube. Let us add cos x plus cos 2 pi by 3 plus x and cos 2 pi by 3 minus x. If we are getting 0, then we can directly say that we can get the answer by doing this, that is 3 times of a into b into c. Let us do the thing. So this is the logic behind this question we are going to use. So first of all, let us check a plus b plus c is equal to 0, that is cos x plus cos 2 pi by 3 plus x plus cos 2 pi by 3 minus x, cos x plus. Now cos x plus y identity is cos x cos y minus sin x sin y, plus here also cos x cos y minus sin x sin y. So you can cancel this step, and this 2 will be getting added. That will be 2 times of cos 2 pi by 3 cos x. Now cos 120 degree, I guess we have already used in the previous question, that is cos 120 degrees minus 1 upon 2. So minus 1 upon 2, this will be cancelled, cos x minus cos x. So yes, it came 0. So we can use, see, this is the part of the solution, and whatever I explained you, that identity that you have to do. So this is the part of the solution, I'm rubbing it, you have to mention in the solution, okay, equal to 0. This is coming equal to 0. So as a plus b plus c is equal to 0, then a cube plus b cube plus c cube will be equal to what? 3abc. Okay, so we directly do 3 into cos x into cos 2 pi by 3 plus x and cos 2 pi by 3 minus x. Okay, now you can use the identity here and here also, but let us use cos x cos y identity, right? So for that we need 2. So I'm multiplying by 2 and dividing by, and multiplying in the denominator also. So 3 2s are 6 upon no, don't multiply this 2, because we 2 here, this 2, okay, this 2 cos x cos y. So 3 by 2 cos x, and this 2 cos x cos y will give you, what is 2 cos x cos y? What is the identity of 2 cos x cos y? That is the cos x plus y plus cos x minus y. Okay, cos x plus y and plus of cos x minus y is 2 cos x cos y I have used. So this you can cancel, and here this will be cancelled. 3 upon 2 cos x. Okay, this is 120. See, 2 pi by 3 plus 2 pi by 3 will give you what? This will give you 4 pi by 3. So cos 4 pi by 3 plus, and what will be the answer of this? This will be cos 2x. Okay, then so this cos 4 pi by 3 plus cos 2x. Now this cos 4 pi by 3 is cos 240 degree, or it is 2 times of what? 120 degree, and the answer is minus of half only. Okay, and this cos 2x. Now after this step, what you can do, place the value of cos 2x as 2 cos square x minus 1 and minus of half. Okay, 3 upon 2. Now take the LCM. So, or else you do one thing, 2 cos square x minus, this will be minus 3 by 2. So 3 by 2. Now take LCM, 4 cos square x minus 3 upon 2. Okay. Wait, the cos x is going on, that cos x I have been written cos x. Now multiply this cos x inside. So 3, this 2 and this 2 will give you 4. Now multiply this cos inside. So 4 cos cube x minus 3 cos x. Now by the identity you already know this is nothing but cos 3x. So like this, 3 by 4 cos 3x. Okay. So children, that's it for the today's video. I think we have taken a very good quality of questions which can make you so many things clear. So I will share you more questions to do, and I guess we can just give end to the trigonometry chapter. And whatever I have taught you, please go through all these things very thoroughly, because from that only you will be asked in the examination. Okay, and that's it for the trigonometric section. Okay, and after that means 3.5, 3.6, 3.7, these are the very important exercise, and this will only come in the examination, or else all the other exercises are skipped because of that reduction in the syllabus. Okay, so next I will tell you what we will be going to take. Till that, please practice for this trigonometric chapter nicely. Okay, thank you so much. Have a nice day.